So this is where we left off yesterday. We're going to be talking about the relationships between median and mean. I mean, we saw that they're completely different things, right? The mean is the average of data, whereas median literally means the middle of the data. I'm just trying to figure out where it is because I want to make sure I write exactly what is in here. Help me, Obi-Wan Kenobi. You're my only hope. I am lost. This is not a good recording. I'm already going to have to start it over again. Oh, there it is. I found it. Okay. There we go. All right. This is actually important information. It has come up before in IB questions. It says the median is the only measure of center because mean, median, and mode are technically all different measures of the center. The median is the only measure of the center that will locate the true center of data, regardless of the data set's features. So the median is literally the middle, and it doesn't matter what the data set's about, how many things are in it. The median is always going to be the dead middle. Where's my pen? There it is. So for symmetric distributions, and this is only for symmetric distributions, and I'm going to draw one to the best of my ability, somewhat like that, bell curvy. For a symmetric distribution, the median, which would be in the middle, would also happen to be the mean, which is pretty neat, or they're relatively equal. This would be the median and mean. Wow, that is just awful. Median and mean. Now, this is not the only type of symmetric distribution. This is the best kind. It's a bell curve. But a symmetric distribution is just any distribution that is symmetric, right? So we could have things that have more than one hump. We can make like camel distributions. Like that. Well, for this one, because it is symmetric, the median and the mean would still both be generally right in the middle. But that's only because they're symmetric. Now, I don't know if it hasn't come up yet. It'll come up in a minute, but I'm going to go ahead and mention it anyway. And I was talking about this yesterday with Alberto, I believe. We were talking about how the top of the bump just represents where the mode is, right? So this symmetric distribution on the right would, as long as it was perfectly symmetric and those two bumps were exactly the same height, we would call this a bimodal distribution because it has two modes. Any more than two, we don't give it a name, but just so you know. That's going to be later in the notes, but I wanted to say it because I'm looking at it. Was that the end of that page? Yes, that is the end of that page. Okay. So if the data has symmetry, both mean and median they will both mean and median accurately measure the center. Oh man, this thing is squeaking so hard, my arm is covered in goosebumps. I wish I couldn't hear it. I wish I couldn't feel it. For non-symmetric distributions, though, so we're talking about things that are skewed. We have positively skewed distributions. We have negatively skewed distributions. So let's go ahead and draw a positively, ooh, whoa. My knuckle was dragging the board. A positively skewed distribution peaks to the left. So like that. So this is positively skewed. For this one, again, the top of that bump is where we're going to find our mode. The median would still be in the middle, so somewhere halfway along the x-axis, if you want to think about it that way. So we would have a median somewhere around here. But because a majority of the data lies to the right of the mode, meaning the area under that curve, majority of the data falls to the right of the curve, the mean is actually way on this side. So for a set like that, you wouldn't be able to say both the median and the mean accurately measure the center. Instead, you would need to figure out what it was you were trying to analyze to figure out which one of those two values means more to you. And for a negatively skewed, that one's going to peak to the right. Wow, my knuckle dragged on the board again. Knuckle dragger today, I guess. Going to peak to the right. And it's going to basically be the exact same image, only flipped around. So our mode is still going to happen here. Median always happens in the dead middle. And for this one, because a majority of the data lies to the left of the mode, our mean ends up being to the left of the median. Of course, picture not drawn to scale, right? I mean, that's always the rule, but and for some reason, you just have a string of data, and the question is missing. Right, but the part where it says example, the number of faulty products returned to an electrical goods store over a 21-day period is. The words are missing. I bet you that picture of those two things is because on my end it was a white box. I bet you I accidentally covered up the question. Might be. Okay. Well, anyway, basically this string of numbers is the number of faulty parts found or returned to an electrical goods store over a 21-day period. And we're supposed to find the mean, median, and mode. First of all, what is the very first thing we're going to have to do to tackle any one of these? It's got to be ordered data. This is not ordered data, so I have to put them in order. I will save you the trouble and just list it out for you. It goes 1, 1, 3, 3, 3, 3, 3 4s, so 4, 4, 4, a pair of 5s, a pair of 6s, a pair of 7s, a triplet of 8s, and a triplet of 9s. There you go. So there are 4 3s. 3, 3, 3, 3. Now we can find our mean, median, and mode. I don't. Okay, anyway. A, the mean. What you're supposed to do is add them all up. So we're going to say x bar equals, and the reason why I'm using x bar is because this is a sample, because it said it was a 21-day period. I mean, we're assuming that this place is open a lot more than just 21 days out of the year, right? So this is a sample, so its mean would be x bar. If it was a population, remember we would use mu. Okay? So x bar would be 1 plus 1 plus dot, 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 all the way out to plus 9. And we're going to divide by 21 because it was 21 days. And what we find is that x bar is about 5.38. Remember, we're rounding to 2 sig figs unless told to do otherwise. Unless it's a terminating decimal. If it terminated, you would stop there. So there's about 5.38 items returned on average. the median is just the number in the middle. There is a formula for that. So since there are 21 objects, n equals 21, the formula is, do I have a symbol for this? No. You just say n plus 1 divided by 2, so it is the 11th term. 11 is not the median, it's the 11th term. So we just go figure out what the 11th term is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 5. So median is equal to 5. Yes. Because n is 21. So it's 21 plus 1, and then just divide by 2. Let's, just for the sake of argument, let's say it was an even number of terms. Like, let's say there had been 20 terms instead of 21. Then I would have had to have found the 11.5 term, quote unquote, which is the average between the 11th and the 12th term. I meant 10.5. Excuse me, not 11.5. The average of the 10th and 11th term. I'll be okay. I can math. Because 5 is the 11th term. It's the term, that's the term that's in dead middle. There's 10 terms to the left of it and 10 terms to the right. No, you only have to do that if there's an even number of terms. That's what I was saying. If there's an even number of terms, then you have to find the average between the two middle terms. And the mode would just be the most common one. So the mode is just 3. So which of those 3 numbers is more important to you? Well, it just depends on what metric you're using, you know? I mean, they could advertise something like, you know, most people only have to return 3 things to us. And they could get away with it because it's the most common number of things that's returned. But the average person might have to return 5.38. It's a lot more than 3. So that's why when we look at class averages on tests and stuff, the class average doesn't tell us actually that much information. Even though so many people focus on it, including a math teacher, me, focus on what was the average, even though I know the average alone is not enough information. And when we learn a little bit more about distributions, you'll see exactly what I'm talking about. All right. Yeah. Mm-hmm. So if you have a bimodal situation, which is actually what we're about to write, then you would say it's both of them. But if there's more than that, you say there is no mode. Why did they draw the line at 2? Magic? I don't know. There must be a reason. I just don't know what it is. So if a data set has 2 modes, we call it bimodal. If a data set has 3 or more modes, we say there is no mode. We do not use mode. I can't take it anymore. Squeaking's driving me nuts. New tip. For a symmetrical distribution, mean, median, and mode. For symmetrical distributions, you already saw me draw the picture, and I put median and mean, or I can't remember. Flip back. I put median and mean right in the middle. But I've already told you, the top of the highest spike, that's also where the mode is. So for symmetrical distributions, mean, median, and mode should be about equal. Should be about equal. Now, we know in the case of a bimodal distribution that wouldn't be the case, right? But if you have a symmetrical distribution, typically it looks more like a bell curve with a single mode. And when you have one of those, the mean, median, mode are going to land probably right around the same area. They might not be identical, and they probably wouldn't be identical, but they'd be darn close. But here's the thing. This is a one-way street. So if you know a distribution is symmetrical, then yes, the mean, median, and mode are relatively equal. But just because you have a mean, median, and mode that are relatively equal does not mean that you have a symmetric distribution. So all about equal does not, did I use the word imply? Yeah, does not imply symmetric distribution. It may hint at it. And you could even say something like that in an IA. If you were to do a statistics-based IA, you could say, well, when I analyzed all my data, I found that my mean, median, mode were pretty much right on the same number, which may hint at, you could say that, this may hint at the population being a symmetric distribution, which would then allow you to maybe do a little bit more math for your IA if you wanted to. You gonna make it, Bryce? Oh, okay, just make sure. He's about to nod out. Tell you right now, if you fall asleep and fall out of that chair, I'm gonna laugh. So you know. Okay. If 6 people have a mean mass of 53.7, find their total mass. Yes. So what you're going to do is the sum of masses divided by number of people is 53.7. So if you want to know what the sum of the masses is, you just multiply both sides by 6. Ta-da. What does that give me? 322.2. You literally just multiply both sides by 6. There you go. And if my calculations are correct, that is where 2.1 ended. 20.1, excuse me, 20.1. The next page says 20.2, correct? Okay. So now that we have officially finished 20.1, homework number 1, which is on Blackboard, you have to click on the assignment to see the questions, has now been assigned. It would be due tomorrow, but its final date for full credit would be the next day. All that makes sense? And it would be great if you could get the homework to me the next day. So we're going to stop recording.